Okay, lesson 5.5, which is the last lesson in chapter 5. We'll be talking about multiple angles, so sine of 2x or cosine 3x, so on and so forth. We'll be talking about the product to sum formulas and sum to product formulas. So let's start in with the double angle formulas. So we have the sine of 2u and equal to 2 sine u cosine u, and all these formulas are on the handout that I gave you. Cosine of 2u, we have three options that are listed here. And the tangent of 2u is just one option. So if we're solving for the sine of a double angle or tangent, it's pretty easy. You just have one formula to work with. But when it comes to cosine, you got three of them to choose. They'll all work, but some of them may work it faster than others. And so it depends on which one you pick. Okay, so let's look at example 1. So solve cosine of 2x minus cosine x equals 0, and our interval is all real numbers. So here we have cosine of 2x. So we're going to write a double angle formula for that. And since we have a cosine in the problem, I'm going to pick the middle one for cosine of 2x. So I'm going to write it. So I'm going to use this formula here. So the cosine of 2x becomes 2 cosine squared x minus 1. And then we have our minus cosine x equals 0. And now I'm going to put it in the form that looks a little bit more familiar for a quadratic. We'll write it 2 cosine squared x minus cosine x minus 1 equals 0. And we'll see if we can factor these. So factors of 2 cosine squared x would be 2 cosine x and cosine x. So both of them are minus. And so one has to be negative, and factors of negative 1 are just 1 and negative 1. And so the negative 1 we'll put here, and a plus 1. Remember, these equal 0. So now we can solve them individually. The first one here, this one gives us cosine x is equal to 1/2. And the other one, cosine x, equals negative 1. Okay, since the interval is all real numbers, we'll do the first one first. Where is the cosine of x equal to 1/2? And that is, well, let's do it over here. X equals arc cosine of 1/2. And that's equal to pi over 3. And then we have to add the plus 2n pi. And it's also equal 1/2 at 5 pi over 3 plus 2n pi. Okay, so that's for this one here. Now let's do cosine x equals 1/2. Well, x is equal to pi plus 2n pi. So we have three answers. We want to make sure we box all three answers. Okay, so that's example 1. Now let's look at the next example. Example 2, solve sine 2x plus 4 cosine x equals 0. And again, our interval is all real numbers. So sine of 2x, that's easy. We just have one formula for that. So we're going to write that as 2 sine x cosine x. That's this, sine of 2x. Then we have to add 4 cosine x equals 0. So now what are we going to do with this? Well, we can factor a 2 cosine x out of it. So let's do that. 2 cosine x times. So the first one leaves us a sine x plus 2. And that's equal to 0. So So we have we'll do the first one. A 2 cosine x equals 0. And get rid of the 2. So cosine x equals 0. And where is that? That's at x equals pi over 2. Then we have to add our plus 2 n pi. And at 3 pi over 2 plus 2n pi. So that takes care of the first term, the 2 cosine x. Put a box around these answers. Now let's do the sine x plus 2 equals 0. So I'll come up here. So we can say that sine of x, we'll subtract 2 from both sides, is equal to negative 2. Well, right away we recognize there's no solution for this because negative 2 is outside the range. The range for sines and cosines has to be between negative 1 and 1. And so a negative 2 just means we're out of the range, so this is no solution. You don't have to write no solution. Just cross it off and box your solutions like I did right here. Okay, example 3 says use cosine u equals 3/5 in the fourth quadrant to find sine of 2u, cosine of 2u, and tangent of 2u. So the first thing we want to do is draw our fourth quadrant angle. So let's say this is the origin. And we know the cosine u is 3/5. And so we're going to count 3 from here. And then since it's 3/5, we know that the hypotenuse is 5. And so that's going to make, here's the hypotenuse. And I knew where to draw it because this is a 3, 4, 5 triangle. And so here's the angle u. And this is 3. And this is a negative 4. So now what we want to do is, we know what the cosine of u is. We'll just write the sine of u is going to be equal to minus 4 over 5, the opposite over hypotenuse. And we might as well write the tangent of u, just in case we need it. Well, we do, because we want to find the tangent of 2u. Okay, so the tangent of u is opposite over adjacent. So this is a negative 4 over 3. So we have the cosine of u is 3/5. We have the sine of u, and we have the tangent of u. So now we can do our calculations. So the sine of 2u, the equation tells us it's 2 sine, we're going to call it theta, but it's going to be u, 2 sine u cosine u. And so this is equal to 2 times the sine of u we found is negative 4 over 5 times the cosine of u, which is 3/5. So this is, multiply all the numerators. 2 times negative 4 is negative 8, times 3 is a negative 24 over 25. So there's the sine of 2u. Now we'll do the cosine of 2u. And so which equation to pick, it doesn't really matter. Let's just use 2 cosine squared u minus 1. So 2 times cosine squared u, well, the cosine u is 3/5, so it's 3/5 squared, and then minus 1. So this is 2 times 3 times 3. This is 18 over 5 squared is 25 minus 1. So this is 18 25ths minus 25 25ths equals a negative 7 25ths. Now the last one, tangent of 2u. So formula is, this is the sine of 2u over the cosine of 2u. Well, since we already found these, makes it a little bit easier. The sine of 2u is a negative 25. Oh, that's negative 24. Why did I write 25? I don't know. I'm going to fix it right now. I'll put it in red, which indicates I made a boo-boo. So this is minus 24 over 25. And so now we're back to solving the problem. Tangent to u is a negative 24 over 25 divided by the cosine of 2u, which is a negative 7 over 25. So this is negative 24 over negative 7, or 24 sevenths. And that's the tangent of 2u. Okay, example 4. This is an interesting example. So we want to derive a triple angle formula for cosine of 3x. So we'll start off with 4 cosine x. And that's it. We're going to stop right there. We can't really simplify that any. So this is a derivation of a cosine 3x going to be 4 cosine cubed x minus 3 cosine x. Okay, that was a fun problem. Okay, now we got some power reducing formulas. So, for example, here's sine squared u. We know it's equal to 1 minus cosine squared u, but here's another formula for it, and it's called a power reducing formula. Cosine squared u is equal to 1 minus cosine 2u over 2. And then here's cosine squared u, and here's a tangent squared u. Now, one thing to note, let's go back to look at the sine squared u. What if we had a sine squared 2u? Well, that's going to be equal to 1 minus, instead of cosine 2u, it's going to be cosine 4u. And still over 2. So that's how you can do a power reducing formula for a double angle. You just double this angle here, the cosine 2u becomes a cosine 4u. And the same with the this one, the cosine squared u and the tangent squared u. It worked the same way. Okay, let's do an example. Let's look at example 5. We're going to rewrite tangent to the fourth x as first powers of cosines. What that means is we don't want a cosine squared or cosine cubed or anything. We just want a cosine to the first power. So the first thing we're going to do is break up this tangent to the fourth x is going to be tangent squared x times tangent squared x. Because we can deal with tangent squared x, because the tangent squared x is a 1 minus cosine 2x over 1 plus cosine 2x. Well, this is tangent of tangent squared x, so we have to square this. So now we're going to look at the numerator. We're going to FOIL that out. The numerator becomes 1 minus 2 cosine 2x plus cosine squared 2x. That's the numerator. And the denominator becomes 1 plus 2 cosine 2x plus cosine squared 2x. Okay, so what do we have to deal with now? We have the cosine squared of 2u. So we have to get rid of that squared term. So let's off to the side just solve for cosine squared of 2x. So using the formula, cosine squared of 2x is going to be 1 plus cosine, instead of 2x, it's going to be 4x all over 2. So this is what we need to substitute in for this right here. So I'm going to break up the fraction, that's going to be 1/2 plus cosine 4x over 2. And that's what's going to go in place of the cosine squared 2x. So let me do that. So we have a 1 plus, oh, it's minus. 1 minus, I'm just rewriting the numerator right here. 1 minus 2 cosine 2x plus, now I'm going to substitute this in, 1/2 plus cosine 4x over 2. And then the denominator is going to be 1 plus 2 cosine 2x, and that's the same thing, plus 1/2 plus cosine 4x over 2. Well, we've done it. The answer is in single powers of cosines, but now we need to clean up this. We can't leave it like that. And so what I'm going to do is convert everything to, well, I'm going to multiply top and bottom by 2. I think that will take care of it. So 2 over 2 to clean up the fractions. So we have 2 minus 4 cosine 2x plus 1 plus cosine 4x. That's the numerator. And the denominator is going to be 2 plus 4 cosine 2x plus 1 plus cosine 4x. So finally, this is going to be, add the 2 and the 1, so 3 minus 4 cosine 2x plus cosine 4x, and the denominator is going to be 3 plus 4 cosine 2x plus cosine 4x. Okay, you can't simplify that anymore, so we're going to put a box around that. Okay, let's look at the half angle formulas. So this is the sine of u over 2, or cosine or tangent of u over 2, and these are the 3 equations that are given on the handout. So let's do an example. Example 6, find all solutions for cosine squared x equals sine squared x over 2. And this time we're going to use the interval 0 to 2 pi. So we want to change this sine squared of x over 2, and that's going to be, we're going to use the sine u over 2, but we're going to square both sides. So let's rewrite the equation. We have cosine squared x is equal to sine squared x, and we're going to write that as the square root of 1 minus cosine x over 2, but this has to be squared since it's sine squared, so we'll square it, which essentially we're eliminating the radical sign, so we can just write cosine squared x is equal to 1 minus cosine x over 2. So what we want to do is set this up, set it equal to 0, so we're going to multiply both sides by 2, gives us 2 cosine squared x. We're going to add cosine x to both sides, so plus cosine x, and we're going to subtract 1 from both sides, minus 1 equals 0. And this can be factored into 2 cosine x, and cosine x. Factors are, well, factors are 1 and 1. We have a plus and a minus, so this has to be a negative 1, and this is a plus 1. So this is equal to 0. So now we have our two terms. First term, 2 cosine x minus 1 equals 0. So that gives us cosine x equals 1/2. Do it up here. Cosine x equals 1/2. And in the interval 0 to 2 pi, that's going to give us x equals pi over 3 and 5 pi over 3. And then we have the next one, this one here, so we have cosine x equals negative 1, cosine x equals negative 1, and that leaves us x equals pi. So here's our three answers: pi over 3, 5 pi over 3, and pi. Okay, example 7, writing products as sums or differences using a product to sum formulas. So listed on your handout, there's 4 product to sum formulas, and then in the next example, we're going to look at sum to product formulas. There's 4 of those too. So let's first do the product to sum. So this is a product, sine 5 theta, cosine 3 theta. So that's a product, and we want to write it as a sum or a difference. Well, we look at the formula, and this is equal to 1/2. So then it's the sine of u plus v. So it's the sine of 5 theta plus 3 theta. And then it's plus the sine of 5 theta u minus v. So 5 theta minus 3 theta. So this is a pretty easy one. So it's just equal to 1/2 times sine of 5 theta plus 3 theta is sine of 8 theta. And plus the sine of 5 theta minus 3 theta is 2 theta. So it's the sine of 2 theta. I could put parentheses around the 8 theta. Doesn't need it, but I'll just do it for consistency. So that's it. Easy enough. Well, let's look at example 8. Now we're going to use the sum to product formula. So here we have a sum. That's a sum, and we want to write that as a product. And we want the exact value, which means you can find these on a unit circle. If not, you can use your calculators to get an exact value. So anyway, let's go back to this. So the sine of, say, u plus the sine of v is going to be 2 sine, and then we have u plus v, so it's 195 plus 105. This is divided by 2. And then times the cosine of 195 minus 105, and that's over 2. So this is going to be 2 sine. So 195 plus 105 over 2 is 150. So it's 2 sine of 150. These are degrees. Cosine of 195 minus 105 over 2 is cosine 45 degrees. Now, looking at the unit circle, we have 2 times the sine of 150 is 1/2. And the cosine of 45 is square root of 2 over 2. So final answer, this is 2 square root of 2 over 4. But this 2 will cancel with that 2. So it looks like it's just the square root of 2 over 2. Alrighty, we have reached example 9, which is our last example in chapter 5. And this is we're going to solve it as a sum to product. So let's look at it. We have solved the sine of 4x minus sine of 2x equals 0, and we have our interval 0 to 2 pi. So let's take care of the sine of 4x. That's going to be a double of a double angle formula. So this becomes 2 cosine of 4x plus 2x over 2 times the sine of 4x minus 2x over 2. And remember, this is equal to 0. So now we're going to simplify this. The 2's cancel. Well, let's just take care of it this way. So we have 2 cosine. So 4x plus 2x, 6x over 2 is 3x. And then sine 4x minus 2x, that's 2x. 2x over 2 is just x, so sine x. And that is equal to 0. So now we can split it up. So we have a 2 cosine 3x equals 0. That's one of them. And the other one is sine x equals 0. So let's take care of the first one. We divide 2 cosine 3x, divide both sides by 0, we get cosine 3x equals 0. And now since we have a multiple angle, the 3x, even though we have our interval 0 to 2x, because this is a multiple angle, we're going to have to do our 3x, we have to write it 3x is equal to arc cosine of 2x. Where did I go? Okay, arc cosine of 0. And that's equal to pi over 2. And we have to do our 2n pi before we get rid of, or before we divide both sides by 3. So this gives us x, we're going to divide everything by 3. X is equal to pi over 6 plus 2n pi over 3. Now, just to make things a little easier, I'm going to rewrite this as x equals pi over 6 plus, I'm going to change the 2/3 into 4/6, so it's going to be 4n pi over 6. So now we keep on finding solutions for this as long as they're in the range of, in the interval 0 to 2 pi. So when n is 0, we have x equals pi over 6. Now when n is 1, we have pi over 6 plus 4 pi over 6, so that is 5 pi over 6, still in the interval. Now if n is 2, we have pi over 6 plus 8 pi over 6, so that's 9 pi over 6. And then, what if n is 3? Then we would have pi over 6 plus 12 pi over 6. That would give us 13 pi over 6. But the problem is this isn't in our interval because this is greater than 2 pi, so we're just going to cross that one off. So here's the answers for the first batch. Now we're going to go back up to here where we have the sine of x equals 0. And that gives us x equals 0 and pi. So we have 5 answers for this problem. 5 answers boxed up, and this is the last of our examples. So we're done with chapter 5. I'm sure you are going to be disappointed that we're going to move on to a different chapter, but that's the way life goes.